Okay, relating rational exponents to powers. So this is our example of a rational exponent. Sometimes they're also called radicals. So keep that in mind. The book might call this a radical exponent, but it deals with roots. Okay, and we're used to seeing a root with nothing here. This is just kind of empty space. But when we talk about, usually that's how they refer to a square root, it's actually implied that there's a number 2 here with a square root. We just don't write it in. Okay. So with that being said, a square root is usually written with no number there. But anytime we're doing a different type of root, we need to write a value there. And that's what this m variable stands for, some value number. A square root essentially means, if we're looking at 9, we're looking for 2 numbers that multiply to equal 9. Okay. If we're looking for a cubed root of something, x, we're looking for 3 numbers that multiply to x, and then so on and so forth. If there's 4, we look for 1, 2, 3, 4 numbers, and that's essentially the idea between the root. And then this is just an exponent inside the root. So you can apply this exponent before, or you can apply the exponent after. It's completely up to you. Okay, maybe we'll try to go through the example that way. You'll start to notice that one version will tend to be easier than the other. And that's equal to, this is our power. We're used to seeing, x to the power of n, and a whole number is really just over the number 1, okay? And this time we're using that letter m. So what we're going to do here is we're going to relate this to a rational or a radical value. So we have our exponent, and they've written it as a fraction, this exponent. Our base is always going to stay the same. Our x is going to be our base. So this is the equivalent of writing 27, and in radical form we have our root. But this time our root, if you notice, okay, our m value of the root is going to be, I should use a reddish color here since that was red. That's going to be our m value. So we're going to replace that value right here. So we're looking for the third root. That's not a good color. There you go. Third root of 27. And then the n value, okay, and this one's a little, not that it's trickier. It can kind of be placed here, or it can kind of be placed here with what you would consider like a set of brackets outside. That's again where I said that the order that you do it in, it doesn't technically matter. It's just one root will be much easier than the other. So since we've written it underneath the root, we'll write it that way. And then I'll show you another example where it's not that way. So we're going to say that, or third root of 27 to the power of 4. Okay. So think of it like we're looking at it 2 different ways. Okay. I can write it this way, or I can write it this way. Now that we've written it as a radical, it'll be a lot easier for us to actually evaluate what this is. When written as a fraction, this is really difficult to figure out what this is going to be equal to. But we can do roots, and we can do them with our calculator or our mind. It's completely up to us. Now, I'm going to split this page into 2, and I'm going to show you that clearly one of these is going to be a lot easier than the other. It doesn't mean that version's always easier. It's just kind of circumstantial. So in this case, we have the third root of 27, and the power of 4 is underneath that, okay? And in this one, we have the third root of 27, and the power of 4 is kind of outside of that. We'll do this version first. So according to BEDMAS, we would do kind of what's underneath the root. So 27 to the power of 4, which I cannot do in my head. 27 to the power of 4, here's a number. 5 million? How many commas do I have? 531,000. Yeah. Okay, so 531,000. Got to get the rest of that. Poor short-term memory here. 441. 441. Okay, and that's all to the third root after. Again, not something I can do in my head. So I'm going to use our lovely calculator again, and I'm going to find the third root. Now my calculator...
It's 81.
Yes, it is 81. My calculator doesn't quite... See, this only has a square root. It's implied as a square root. So instead...
Would you do 3
the shift
the
button?
square root?
There you go. My shift button will give it to me. Another way you could have done it. So for instance, if this shift wasn't there, so I'll write it in, and you'll see that it is 81. Excellent.
How'd you know?
Good old calculators. But let's say I didn't have that. All of a sudden, I need to do like a fourth root. Obviously, when I hit shift, I don't get a fourth root. So we can actually write things in our calculator. I know I'm digressing. I haven't talked about this point. We can actually write them as that. So I could have written 27. This is my power value. You might have one that actually shifts it to, like, they call it like a superscript. And I could actually write 4 divided by 3. Okay, so I can write all of that in my calculator, and boom, it gives me 81. Don't really have to go through each of those steps. Okay, now let's say we don't have a calculator. This version here is a lot easier to work with. Okay, 27. Well, I'm looking for the third root of 27, which in other words is 3 values that multiply to 27. Okay, I actually know what they are. I could try kind of just going up the chain if I don't. 2 times 2 would be 4 times 2 is 8. That doesn't really work. 3 times 3 is 9 times 3 is 27. So there's something I could have done without my calculator. I know that the third root of 27 is the value of 3. So now we're looking at 3 to the power of 4. So we've kind of broken it into small steps here. And 3 to the power of 4, well, that's just going to be 27 times 3. It ends up being 81 again. Now, if we have a calculator, it obviously doesn't matter which version we kind of use, okay? But you can see whether you put this power underneath the radical or outside of it, you're still going to end up at the exact same answer. It doesn't make a difference, okay?